This video is for the lesson 2.2 homework. All we're doing today is function or not a function. That's it. Okay? So, a function is with every x is paired up with a different y. So, we try to look and we try to see if x repeats. So, on number 1, here's my x's. So, in an ordered pair, x is always the first number. So I have a -2, I have a -1, I have a 0, I have a 1, I have a 2. All of my x's are different. Automatically, that is a function. Now, an x can repeat. Say I added an ordered pair here to the end. 0, 1. Now the 0 repeats, but it's with the same y. That's okay. But as soon as an x repeats 0 and 0, and maybe that 1 is now a 4, zeros are the same and the y's are different. Automatically not a function. Okay? So look for the x's repeating. If you see an x value that repeats, check to see if the y's are the same. If they're the same, you're good. If they're not a function. So let's mark that one out. So on a table, same thing. We just look at the x's. -5, -4, -3, 0. Ooh, -3 again. So -3 and -3, but they're both paired up with a 6. That's okay. The y's the same, so those are still good. A -4 again. Both paired up with an 8, we're still good. -5 again. Both paired up with a 10, we're still good. Again, if that had been maybe a 12, 5 and 10, 5 and 12, not a function. But since all the x's that repeat are still partnered up with the same buddy, that's a function. So with graphs, we do the vertical line test, okay? When it's just points like this, every point, draw you a vertical line through it. If your line touches 2 points like it does here, see how it touches that point and that point? Not a function. But if it touches just 1 point, you're still good. But as soon as it touches 2, it doesn't matter that all the other points are good. It's kind of one of those one bad apple ruins the bunch kind of deals, okay? So with graphs like this, any type of graph, do that vertical line. And you can do it with a pen, put a vertical line on there. As long as it's touching your graph in one spot, it's a function, okay? So if it goes this way, here's where I have kids mess up. And they go, oh, that's a function. Because look, they're like, look, I can put my pen here and it only touches it once. But that's got to work everywhere. If I scoot that pen a little bit to the left, now it touches the function in 2 places. So that vertical line test, you got to be able to move that vertical line back and forth across. Yes, sir. Okay. All right. Equations. So here's how you do the equations. So we're going to use the calculator for these. What I'm going to do, I'm going to start from the home screen here. And I'm going to click this blue graph. It looks like it's got a U on it. And then I'm going to type this in. I'm not going to type the y equals. That's already in there for me. All I'm going to type is the x squared plus 3x minus 7. And then I can see it. And if you need to zoom out, menu, 4, and you just click and it'll zoom out. Oh, menu, 4. So what do you guys think? Function or not a function? Function, because it's a U. Just like this one. Just like this one. It's a U. That is a function. Let's go ahead and do the other equation as well. All right. So I'm going to exit out this red X up at the top. And then I can go back into that blue graph. That just kind of resets everything for you. All right, this says plus or minus the square root of 3x squared. Well, I can't do that plus or minus sign. So what I'm going to do just the square root of 3x minus 2. That's positive. That's that positive sign. But we don't need to put that positive sign in front of it if it's positive. Just like if our answer is positive 7, we don't write x equals positive 7, right? We would just put x equals 7. Okay? And then I'm going to press the down arrow key, and then I'm going to do the negative. So it's a negative sign, and then the square root of 3x minus 2. What about that one? Is that graph a function? What? No.
That is on the side.
Yeah. So this graph right here, if I put a vertical line through it, it touches in 2 spots. Not a function. Okay. Real world stuff here. Temperature is measured every minute over a time period of 1 hour. All right. So that means if I would make a graph, right? Make a graph here. X is going to be my time. Ooh. Y is going to be my temperature. All right. At the 1 minute mark, it's 90 degrees. So we'd put a point at 90 degrees. At 2 minutes, it's 89 degrees. 3 minutes, 87 degrees. So my X's are down here at any point in time. So at the 4 minute mark, is there any way that I could look at the temperature and it's going to say 86 degrees and 88 degrees? Is that how temperature works? No, if I look at the thermometer at 4 minutes, it's going to give me one temperature. It's going to say maybe 85 degrees, right? It's not going to say 85 degrees and 87 degrees. A thermometer, when you're talking about temperature, there's only going to be one temperature at that one point in time, which means every X is only going to have one Y value associated with it. So that one is a function. All right, data is collected on the time it takes students to get to school and the distance they live from school. All right, so I'm going to make a table out of this one. X is going to be the time. Y is going to be the distance. All right, how many of y'all live in town? Okay, how many of y'all ride the bus? Okay, how many do I have, like parents, brothers, somebody drives them? Okay, so here's what we're going to do. Hunter, you said somebody drives you to school, right? Say Hunter lives, and I'm just making stuff up now. Hunter lives 10 miles out of town. About how long does it take you to get to school? Like 15 minutes. Okay. I'm going to use you too, Ezra. Ezra lives 10 miles out of the school. Outside of school. So this is somebody's driving him. Ezra, about how long do you sit on that school bus in the morning? 45 minutes, right? That's bus, right? So they both live the same distance. But their times are different because they're getting here different ways. My kids are the same way. So I'll do me and my kids. I live 5 miles outside of town, right? It takes me 5 minutes to get here. When my kids rode the bus, they lived the same distance from the school. It took them 1.25 hours to get to school. They rode the bus for 1 hour and 15 minutes every morning. And we live 5 miles outside of town. So, if these are my x's and these are my y's, could this situation be a function?
No.
Yes.
Why yes?
Because the y's are different.
Can the y's be different?
No.
Okay, so Destin, why did you say no?
Because the times are the same, but the y's are different.
So the times are the x's. These are the same, but they're buddied up with different y values. Okay? So it's when the x stays the same and the y changes is when it's not a function.